Alright, this video is going to go over the first review quiz that covered the algebra review in Chapter 7. I'll post the solution as well. These are really good problems to review for the semester exam. Make sure you understand. First problem, we're given a point on the graph of f of x, and we're given another graph that's related to f of x in some way. Okay? Now the first thing that I did was I took this equation and I rewrote it. I added 4 to both sides and I got this. Just makes it a little bit easier to tell what's going on. And what we can see is that the x values are being shifted to the right by 1. Okay, so this takes the whole graph and shifts it to the right by 1. So the x's are going to increase by 1. And that's the only thing that's being done to the x values. And thus, if the original x value for this point was 2, the transformed value is now 3. Okay? Now the y's, two things are occurring. One is they're being multiplied by 3, and the other is that we're adding 4 to all the y's. So this results in a stretching vertically by a factor of 3, and then a shift up 4. Okay? And so if you look at the original y value of 7, well, we're going to triple that to 21, and then we're going to add 4 to it, and that's how we get 25. So the answer here is 3, 25. All right, second one. Second one's just a straight up unit circle type problem, and it says find the exact value of tangent of 5 pi over 6 and cosine of 7 pi over 4. These are types of problems you should be very, very comfortable with and very, very fast with and very, very accurate with. So 5 pi over 6 is, if I look at this little diagram right here, is about pi over 6 short of pi. Okay? So if I look at this, I know that it's one of those special values, and the sine of it is 1/2, and the cosine is negative root 3 over 2. Thus, this slope, I like to think of the slope of this, which is the tangent, is negative 1 over root 3. The cosine of 7 pi over 4, well, that's like a pi over 4 short of 2 pi. So that's right here, and it's one of those 45, 45, 90 type things, and that cosine is positive, and it's root 2 over 2. Okay, so if you take this expression, you do some stuff to it, you end up with negative root 6 over 6. And really, if you would have put negative root 2 over 2 root 3, that would have worked fine as well. Okay, next one, just about periodic functions. And first thing is, how do we find the period, or really the fundamental period? Is we just see in terms of x how often this repeats. And so I'm just going to look at the top, and I'm going to see that every 3 units we're at the same place, and that means that the fundamental period is 3. The amplitude, if you remember, is half the height. And so if I sort of think of this having a middle line, or an axis of, I guess, yeah, an axis, well, we go up 2 and down 2 from that point. That means the amplitude is 2. The other way to look at it is from the distance from the top to the bottom is 4. Half of that is 2. Okay. Now we're asked to find f of 100. Well, we obviously don't want to sketch this graph all the way out to an x value of 100. We're going to take advantage of the period here. Well, if the period is 3, f of 0 is the same as f of 3, which is the same as f of 6, the same as f of 9, and so forth, all the way up to f of 99, which is the closest thing that we get that's a multiple of 3, close to 100. And that means that, well, f of 100 is going to be 1 unit further than f of 99. Thus, it's the same as f of 1. Okay, so if I look at this graph, f of 1 is 2, and thus f of 100 must be 2. Okay, you should be able to follow that logic and figure that one out. All right, next problem. We're asked to find the angle whose cosine is the same as the cosine of 7 pi over 6. Okay. Now, a very common mistake that people make will be to say that the answer is 7 pi over 6, because it's like, well, this is the inverse cosine of the cosine of 7 pi over 6. The inverse undoes the function, thus the answer must be 7 pi over 6. But we have to remember that inverse cosine is only the range, especially, well, for this capital C, is only between 0 and pi. And so we need to find the cosine of 7 pi over 6, which happens to be right there, and that cosine is negative root 3 over 2. And then we need to say what angle has the same cosine of that, but has to be between 0 and pi. And that angle is 5 pi over 6. So the answer to this is 5 pi over 6. Important to note that inverse cosine is the range of it has to be between 0 and pi. Similarly, if I'm looking at inverse sine, okay, and it's a capital S, then that is going to give us a result that's always in these two quadrants, but specifically it's between negative pi over 2 and pi over 2. Okay? All right, so we do number 5, and we are affected again by the fact that this is the inverse cosine of negative 3/8. We don't need to find this angle, we just need to know that, okay, this is an angle that has to be in the second quadrant. It's not in the third quadrant because I know that inverse cosine is in the first two, between 0 and pi. And the x distance is 3, and the radius or the hypotenuse is 8. We can find the y. It's just root 55, doing Pythagorean theorem, and then thus the sine is root 55 over 8. The next one. Find the angle whose tangent is negative 1 over root 3. Now, there are two places where that could occur, but remember, inverse tangent is in these two quadrants, between negative pi over 2 and pi over 2. Okay? So I like to think of tangent as slope. Well, this is like the change in y, and this results in a sine of negative 1/2. Okay? This results in a cosine of root 3 over 2. That must be this right here. Okay? The longer side is cosine, shorter side is sine, and the angle there is negative pi over 6. Not 11 pi over 6. It has to be negative pi over 6 because inverse tangent, the range of that is between negative pi over 2 and pi over 2. Okay? All right, next one. It says, give me the cosine of the angle no, this is not how you say it. Give me the angle whose cosine is the tangent of 7 pi over 3 divided by 2, negative 2. Okay? First thing is we got to find the tangent of 7 pi over 3. All right? Well, that's like 2 1/3 pi. So we're talking about right here. Okay? This is a steeper one than this, and I just remembered that the tangent of this is root 3. Okay? Divide that by negative 2. That means that we're finding the angle whose cosine is negative root 3 over 2, and that has got to be in the first two quadrants. Okay, and we're talking about this one here. Again, that's 5 pi over 6. All right, number 8. This is an algebraic simplification problem. It's one of those complex fractions. We look and we see x, y, you know, as the denominator of the numerator, and x squared, y squared as the denominator of the denominator. And we sort of say, what can we multiply the top and the bottom by so that we clear out those fractions? Well, we could multiply by x squared, y squared. And when we do that, well, we do that here. We get x, y squared, because one of the x's cancels with this x, and then we still have the y squared. And then we multiply it here. One of the y's cancels, and we have x squared y. Do the same thing on the bottom, but here the x squareds cancel, here the y squareds cancel, and we're left with y squared minus x squared. Okay, then we look at it a little bit closer, and we see that on the top we can factor out an x and a y from each term, so we do that. And on the bottom it's the difference of squares, so we factor those. Then we see we have a common factor that we can divide out, and we're left with xy over x plus y. And algebraically, we really can't do anything else with that. All right, number 9. Number 9 is simply put in your calculator. Inverse sine of 3/5 minus inverse cosine of negative 1/3. Make sure you're in degree mode. Make sure you round correctly, and you get your answer. All right. Number 10. City's at 41 degrees north latitude. Okay, 41 degrees north latitude. That's from the equator. And so this is where the city is right here. Okay. It says, how far is it to the South Pole? Okay, so the South Pole is down here, and we're talking about the distance, this arc length, along the surface of the Earth. All right? So if you want to think of the circumference of the Earth is 2 pi times 3,963. This arc length is just a fraction of that circumference. And what fraction is it? Well, it's 131 degrees total, because this is 41 and this is 90. And so that fraction is 131 out of 360. We multiply that by the circumference, and we get the answer. All right, number 11. We're given the we're given the cosine of an angle, and we're given that the tangent is greater than 0. We're asked to find the exact value of the cosecant. Okay, so I don't need to find the angle. All I need to know is that the cosine is negative 2/3 and the tangent is positive. That means I'm down here in the third quadrant. All right, the cosine could be negative up here in the second quadrant, but since the tangent is positive, I'm in the third quadrant. And I can see that the sine of this angle is negative root 5 over 3, and thus the cosecant is 1 over the sine. It's the reciprocal. It's negative 3 over root 5. Or if you rationalize, you get negative 3 root 5 over 5. Okay, number 12. We're given a point that the terminal side of an angle contains, which is negative 12,5. So I can draw this little triangle. I can see that this distance is 12, this distance is 5. Using a Pythagorean triple, this distance is 13. We're asked to find the value of the cosine. That's got to be negative 12 over 13.